I am going to solve this question for you. So we've been given the equation of a circle and we want to find the shortest distance from the circle to this point. So the first thing I want to do is find the center of the circle because that's going to give me some information. And then I'm also going to use the radius to get to the edge of the circle. But first of all, let's just turn this into our normal circle formula. So what I'm going to do is change colors. So I'm going to put the x's together, x squared plus 6x, and then something goes here. So remember, halve this and square it. And then the y's, so y squared minus 8y, what would go here? Halve this and square it, so 16. And then let's put this over the other side. So negative 21, bringing this across. If I've added 9 there, I'm adding 9 here. If I add 16 there, I'm adding 16 here. All right, so let me just think about what I just did because that, no, that's fine. Okay, so then let's put this together. So x plus 3 squared and then y minus 4 squared. And then if you think about what we've got over there, it's negative 21 plus 25. So I have 4. So that makes the radius 2 because it's the square root of 4. And it makes the center of my circle negative 3, 4. So now I have a lot of information. I'm going to zoom out a bit so I have some more room here. All right, let's swap colors. Okay, so this is the center of my circle and this is the radius. So let me just draw a circle so we can see what's going on. So if I have my center here, if I go out, this is 2, right? But P is out here somewhere or other, right? I'm not entirely sure what's going. Well, I'm drawing it terribly. Actually, it should be down here. Oh, let's do it properly. All right, so if this is negative 3, 4, then over here is going to be like, let's make this 1, 1. Not quite to scale. Let's pretend it is. All right, so this bit here is 2. I don't know this bit. I'm being asked to get from here to the circle. So what I should do now is find this distance and then just subtract this distance. Well, we know how to find the distance. We're going to use our distance formula. So it is going to be negative 3 minus 1 squared. So those are my x's. And then I've got 4 minus 1 squared, square root of all of that. That is a 3, by the way. It's just my bad writing. So that tells us that this is 16 plus 9, square root of that gives us 5. That's a square root of 25. That means this whole distance is 5. So the distance from here to here must be 3. So the distance, the shortest distance from this point to get to the circle is 3. This is another question. So we're given an equation of a circle. So we know what the center is. The center is 7, 6, and the radius is 5, square root of 25. Now I'm being told that PQ is the diameter, and I'm being given some points for PQ. So let's just have a go at drawing that. Oh, that did not work. What just happened there? Give me a circle. Okay, I'm not entirely sure what's happening there. Why is that not working? Please give me a circle. Right, okay, let's just do this. All right, so if I have a center, so this center is 7, 6, so that means that P should be about up here. If it's 3, 9, so this is P, and then Q is going to be over here because PQ is the diameter. So PQ, this is the center, and I'm being told that R is 12, 6, so that's somewhere over here-ish. And so what I need to do is, well, actually, it should be in line with this, shouldn't it? Because they both have the y coordinate of 6, so it's going to be here. So this is R. So we know the rule. We have already talked about this rule that if there is a diameter, it doesn't matter where it hits the edge. If this makes a triangle, this must be a right angle. Okay, we know this rule. They're telling us that all we have to do is prove it. So we're being asked to show that QR, so this line here, is perpendicular. So it also passes through R and it needs to be perpendicular to P. So don't we just have to find the gradients of both of these and show that they're inverses of each other? So if I want the PR, so let's do PR, where am I? What coordinates have I got? Oh gosh, I can't find my things. All right, PR here. So the equation of this, or the gradient of this, sorry, is going to be 3 minus 9 over 11 minus 3. So this gives us negative 6 over 8, which is negative 3/4, sorry. It doesn't like writing over there. So I have negative 3/4. Did I write that down right? What am I doing? PR. Oh, nope, I didn't. That's what looks weird to me. I didn't think that's the answer I wanted. All right, let's get rid of that. I might have if I copy the numbers down correctly. Let's try that again. All right, PR, sorry, these two coordinates. It is, let's do 6 minus 9, and then 12 minus 3. That's a bit better. 6 minus 9, negative 3, 12 minus 3, 9. So we get negative 1/3. All right, so what I'm going to do is I'm going to find the equation of this line now. So using either point P or R, let's use P. It's always easier to use smaller numbers. So, whoops, what am I doing? So y minus y1, which is 9, equals m, negative 1/3, x minus x1, and that is 3. So then I have y equals 1/3 x, negative 1/3 x. Multiply these together, you get positive 1, but then I have to add 9 to this side, so I should get 10. So that is the equation of PR. But now I have to show that this is perpendicular and also passes through R. So I'm just going to do the exact same thing for this line here. So that was PR. Now I'm going to do RQ. So for RQ, I'm going to say, let's get the numbers right. So y2 minus y1 over x. Oh, did I do that the right way? Yep. x2 minus x1. 3 minus 6, negative 3. Negative 1, so it's positive 3. That is an inverse of that. Excellent. So y minus y1 equals mx minus x1. So then we get y equals 3x, and this is minus 33 plus 3 minus 30.